Direct variation is a simple concept but needs to use some tricky kind of calculations to actually do the problems. What it is basically, what it says is, right, as one variable changes in the direction, the other variable changes in the same direction. Okay, that's the simple way to understand it. So Tom, reading this first one here, can you read it out for me?
Does direct proportion exist in the following? The height of the paper and number of sheets in a stack.
Okay, so for example, if you have one sheet of paper, it's not going to be very tall, but the height is increasing, right? You've increased it by however thick this is. And if I keep adding it on, it keeps getting thicker. Right. So that one obviously is. Okay. Now, an important thing to note that I don't think your textbook does, but technically for direct variation, when one variable is equal to 0, the other has to be equal to 0. So for example, if I have no sheets of paper, what's my height?
0.
0, right, okay. So technically, direct variations need to have that as a condition. Just curiously, graphically, what would that look like? If I said when x is equal to 0, y has to equal to 0, what would that look like?
An x, wouldn't it? Like because it's running through the 0 point.
Right, so it has to go through the 0 point called the origin, right? So for direct variation to exist, any graphical representation of this has to go through the origin, okay? Let's keep going. Number of people digging and time taken. So, as I increase the number of people digging a hole, what's going to happen to the time?
It's going to decrease.
Right, okay, so that's not direct variation, right? So, as the number of people increase, the time taken for that to happen would decrease, and they're going in opposite directions, so this one's no. Okay, your maths mark and your height, what do you reckon about that?
No.
Why not?
I'm the shortest person.
Yeah, right. So, really, these are unrelated, okay? So, yeah, it's not really going to make sense. Anytime you have someone who is short and good at maths, or someone tall and is not so good at maths, then that's going to fall apart. So this is unrelated. What about this one? Your maths mark and number of hours studied. So as I study, what do you expect will happen?
That your maths mark will increase.
Right, is that necessarily true? No, okay, right. So something like this is a bit trickier because although logically it seems like it would make sense, it's not something that's objectively true. And another thing to note, remember when x equals 0, y equals to 0? So potentially, if I had 0 hours studied, right, my maths mark is not necessarily going to be 0. It's more likely, but if you have some kind of knowledge already, then probably not. So this one's no. And last one, your height and your arm span. Well, you guys looked at the correlation between them, right? You realized as your height was increasing, your arm span also increased. Okay, so this one is yes. Now, we're not just going to want to be able to identify them, we actually want to be able to solve problems with them, okay? So these are the step-by-step ways we're going to do them. In any problem, we're going to have two variables, okay? And they're going to vary at different kind of rates. The first one is a linear rate. So if they say that they have linear direct variation, that's going to be the equation modeled by this guy. Y equals to kx. I'll explain what k is in a second. Okay. If it's varying by the square of something, we should have y equals to k times x squared. And if we have a cubed kind of variation, what do you reckon that's going to be?
To x cubed.
Yeah, right. They're pretty self-explanatory. And so these, I guess one reason why we've learnt about these kind of graphs previously, so it helps us understand what's actually happening here. Okay? Now, let's look at a question like this. Tom, can you read it out for me?
Solve a problem by agrees directly with the number of coins. 10 coins weigh 5.
Okay, so we don't know yet. Chloe, can you find out how much do 10 10-cent coins weigh?
Where do you find that?
Under the scale. So take 10 coins. You're laughing at Chloe.
So I have to take all the other ones.
Yeah, so only leave 10 on there.
Where do you find that?
I was like, what? About 75.
So let's say 75, that's fine. You don't need to be exact, just need approximate. Okay. So we agree that, as the amount of 10-cent coins increase, the weight would also increase. And they also tell us in the question that it varies directly. Okay, so anytime you see that, you can use this kind of idea. Now, the first step is identify the two variables. Well, you've got a weight, and what else do you have?
The number of coins.
The number of coins, right? So we say let W equal to weight, and N equal number of coins. Tom, what's the second step?
Substituting in.
Substitute given values of X and Y. Now, this is where these guys are going to come into play. When we have a direct variation, we can represent the relationship by Y equals to Kx. Now, what is X and what is Y? Well, all we have to do is look at our equation over here, okay, and realize we actually also have two variables. We have a weight and a number of coins. Now, it won't necessarily matter which one you choose first. Okay, what you can do is, okay, let's choose the first one as W and this one as N. And all I want to do is think about, okay, how I represent this as an equation. Well, I can just say W is equal to K times N. Okay, so that's the linear one that I had over here. In the question, they'll specify that it's linear, generally, or otherwise. So we have this equation over here. Remember, what do I need to do next? Well, Tom said I substitute given values of X and Y. So do I have values for W and N?
Yes.
What do I have?
You have your 10 coins
Yes.
for N, and
Yes.
your W you have 75.
Right, so they have to give me a starting one first so I can work this out. Okay, so I've got W is 75, and I've got N is 10. Okay, so this is K times N, which is just K times 10. Now I can easily find K. What do I need to do?
75 divided by 10.
Cool, so K is equal to 7.5. Okay, why do I want to find that? Okay, so with direct variation, there is something called the constant of proportionality. And that's essentially the rule that links the two variables together, right? In this case, it's going to be linking the weight and the number of coins. And I can use this K value for any stage, for any number of coins or any weight. So this is part 1 that I've just done. Okay. Let me go part 2 here. So part 2 now. How much will 57 coins weigh? So over in this question I had N is equal to 10, but now what will my N value be? So when I had N is equal to 10, I had 10 coins, right? But now if I want to have 57 coins, what should I let N equal to?
57.
Good, okay. So N is just the number of coins. Okay. Now the reason why I want to find this K value is because now I have this K value, I can write the equation like this. What W equals to 7.5 times N, okay? And why that's good is because if I have one given variable, I can find the other really easily, right? So Tom, if I replace N with 57 in this equation, what am I going to get?
7.5 times 57.
Good, okay. Now what that's actually going to give
Let
me...
me quickly do it in my head. 427.5.
What is it? Is it? Oh, mathematician, naturally. Now why is that powerful? Because if you have one variable, you can find the other easily. Once you've found this K value, the variable that links them together. Okay. So I can know that now. The weight of 57 coins will be 427.5. What do you think I need to do for question 3 now? Part 3, sorry.
How many coins just solve for N. 350
Yeah.
equals 7.5 N.
Okay, so you substitute W as 350?
Yep.
W equals to 350. And all you have to do is replace that into your equation. So you've got 350 equals to 7.5 times N. So what's my N going to be?
Yeah, it's 46.66 repeated, so 47 coins.
Why 47?
Because if you pick 46, then that's under.
Good, right. So remember, read the question. You need to exceed 350
Yeah.
grams. So if I need 46.6 to exceed it, then obviously I need to go up to the nearest coin, because I can have 0.6 of a coin. So I'm going to have 47 coins. Alright, last one. Tom, can you read it out for me?
How much will $12 worth of coins weigh?
Okay, so this is kind of like a two-part question. They're asking me to find how much will $12 worth of coins weigh. First I need to figure out how many 10-cent coins are in $12.
120.
Yeah? How'd you get that?
10 times 12.
Good.
It's
It's not always that obvious, right? So $1, 10 coins, $12. Well, I just multiply that by 10. So you 120 coins. And so then you know that your end value will just be 120 in this case. And then you can just subset that into your equation. So you got W equals to 7.5 times 120.
Equals 900 grams.
900 grams.
Oh, 900, yes.
Is that rounded? What's the...
No.
Oh wow, nice. Oh, 900 grams. Any questions?
Yep.